Algebra 2 students. This is our video on the unit circle. I'm going to teach you how to learn the unit circle, how to draw the unit circle over the next couple of weeks. Well, actually, next couple of classes, I guess, at this point. But memorize the unit circle? No, we're not going to do that. We are going to listen to Phish while we do this, though. My second favorite Phish album. It's called Billy Breathes. All right, anyway, let's go ahead and get started. And this right here is why you're not going to memorize the unit circle. You already learned these special right triangles, and if you know your special right triangles, you've got the unit circle down. Okay, what does unit circle really mean? It's a circle with a radius of 1 unit, and that means 1 unit on the coordinate plane. So that 1 unit on the coordinate plane is the like one on each axis, right? So that's the radius of our circle. There's the equation of our circle, which you should remember from geometry, that the equation of a circle is given by x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. And that is the equation of a circle, and this the hk is the center of the circle. That's the center. And so the unit circle has its center, since you see an absence of numbers here in the parentheses, center at 0, 0. Okay, so here is an example of the unit circle. So literally the center at the origin, a radius of 1. So here you have the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And the ordered pairs as you go around the circle are something very significant. We'll talk about that in just a minute. But you can see also that when we're talking about the unit circle, we're talking about opening an angle. This is the initial side of the angle that we're opening. And when you open that angle, we're talking about a spot on the circle. And so, for example, let's do this easy one right here. This would be 45 degrees. This is the angle that we're opening, theta. And that angle can go as far around as you want. Okay, that's called a reflex angle when it's bigger than 180. But when we're talking about this unit circle, that's what we're talking about. That's the angle we're opening. So we're opening an angle from this side. And the angles can be measured in degrees. So 0 degrees up to 90 degrees up here, which isn't listed. I'll go ahead and write it in, 90 degrees. Over here to 180. Down here to 270, which again wasn't listed, but 270. And all the way full circle back to 360. But you can also measure it in something else. When you think about your unit circle, it has a radius of 1. Remember, the circumference of a circle is 2 times pi times the radius. So the circumference of this circle is 2 times pi times 1, or just 2 pi. So the length around this circle, if I was to place a piece of string, take a piece of string and place it here and go all the way around, would be 2 pi. 2 pi what? Well, that's the unit that we call a radian. So we say that this all the way around the circle is 2 pi radians. That means a half circle is pi, 1 pi radian, and a half of a half circle is pi over 2. So 0, pi over 2, pi, 3 pi over 2, 3 halves, 1½ pi, and back to 2 pi. So what the heck's a radian? A radian is a measure around of chunks of a circle. Okay, 1 radian is approximately 57.2958 degrees. It probably seems kind of strange, but what you're looking at, that number of degrees, is based purely on the radius of the circle. A radian is the angle that's made by taking the radius and wrapping it along the edge of the circle. So, like this. The radius wrapped around the edge of the circle. It cuts out a length of the circle's circumference that's equal to the radius. So this length right here is r. It's just curved, so it looks shorter than the flat radius. As we said, half a circle is pi radians. That's 180. And so you can actually use as a conversion factor 180 over pi or pi over 180, and you use those to convert from degrees to radians. You just multiply by the conversion factor. And if you think in science, you should remember conversion factors. You could have like 1 hour, 60 minutes, or 1 mile, 5,280 feet. Those are all conversion factors, and you use that to convert units. But these are the ones you'll use for degrees and radians. How many radians in a full circle? Well, you can fit the radius 6 times and a little bit more, which is approximately 2 times pi, 6.283. So all the way around the circle is 6 and a little bit more radians, or in terms of pi, 2 pi radians. And you're going to see it in terms of pi much more often than you're ever going to see it in terms of just a number. Now, when you think about your calculator in radians versus degree mode, radian mode versus degree mode, this is for radian mode. This is where you'll actually use radian mode. Not a ton, but a little. Degrees is just using a different measurement for the angle. Radians is just using this measurement for the angles. And here we get to the actual meat and potatoes of the unit circle, okay? So what is this telling me? Well, we've got our unit circle, we know about our measurements, and we're going to talk about the pi over 4 family. Here's my special right triangle. The hypotenuse is the 1, so the legs are root 2 over 2. Let's think quickly about how that came about being. If this is 1, and I know the relationship here, that this side is the a root 2 side, this side is the a side and the a side. If a root 2 is equal to 1, I can divide by root 2 and rationalize the denominator by multiplying by root 2 over root 2, giving me root 2 over 2, which is what you see right up here, okay? And at the points on the unit circle, you get an ordered pair, like this. The first value in the ordered pair is the cosine at whatever angle we've cut out of the unit circle here. So the cosine of 45 degrees is root 2 over 2, and then the y value is the sine of that angle. In this case, again, 45 degrees. Now, why is that? Well, let's look at the triangle that we've got here. If this is the angle in question for my triangle, we're talking about the sine, which would be opposite over hypotenuse. Well, this distance has to be root 2 over 2 because that's what our special right triangle tells us. And root 2 over 2 over 1 is just root 2 over 2, so that's the sine of this angle. And then the other one is the cosine, adjacent over hypotenuse, root 2 over 2. So what the unit circle gives you is the cosine and sine values at all of the important angles that we know in trigonometry. So from 0 degrees all the way around back to 360 again. Now this is the, as it says, it's an easy family. This is the 45s, or the pi over 4, or 45 degrees. Why is it pi over 4? Well, if this is a half a pi, what's a half of a half? It's a fourth. 45 degrees is pi over 4. Now what I can do is I can also extrapolate this to the other parts of the circle. There, there, and there. And the other part that's gonna that you're gonna be able to use with this is your knowledge of what happens with a coordinate system. Over here in this second quadrant, first quadrant, second quadrant, third quadrant, and fourth quadrant, over here in the second quadrant, the x value is negative and the y value is positive. The numbers are the same all the way around for the 45 degree angles, or the pi over 4s. So this would be, right here would be 90, so 90 plus 45, which is 135 degrees. Or, if you count in terms of pi, a quarter, a half, 3/4. So 3 pi over 4. And then down here, this would be 180 plus 45, which would be 225. And it would be, if this is 3 pi over 4, pi would be 4 pi over 4. This would be 5 pi over 4. So in degrees, it's 225, and in radians, it's 5 pi over 4. Now let's think about the ordered pair. What's the cosine of 225, or the cosine of 5 pi over 4? It's negative root 2 over 2, because it's that same ordered pair again. What about the sine? Well, here is where y is negative. Below the x-axis is where y is negative. So the sine would also be negative root 2 over 2. And then finally over here, again, you've got all the way to 270 plus 45, 315? No. Yeah, that's right, 315. All right, and if it's 5 pi over 4, 6 pi's over 4, 7 pi over 4. And the cosine and sine there, again, you can find by thinking about your 45, 45, 90 triangle. Positive root 2 over 2 for the cosine, that's the x, because we're in the positive x territory. Negative root 2 over 2 for the sine, because that's the y, and we're in the negative y territory. So that's the first of your unit circle. Let's take a look at using a different triangle on the unit circle. The 30, 60, 90 triangle. Okay, with the 30, 60, 90 triangle, you all, again, already know your sides. You know that with this being the 30 degree angle and this being the 60, and there's your right angle, you know this is A, this is 2A, and this is A root 3. Now again, if I know that 2A is equal to 1, because that's the radius of the unit circle right here, I can find the other distances, and that's the x and the y value, which also gives me the sine and the cosine and sine values for the angle inside the unit circle. So if 2a equals 1, then a has to equal 1/2. If a is 1/2 and we multiply by the square root of 3, we get square root of 3 over 2. This angle is 30 degrees. 30 degrees is 1/3 of the way from 0 to 90. And if 0 to 90 is pi over 2, if that's pi over 2, it's 1/3 of that, which is a sixth. 1/3 of a half, 1/3 of 1/2 is 1/6. So pi over 6. 30 degrees and pi over 6. The x value is the root 3 over 2, the y value is the 1/2. Now, again, I don't memorize. What I do know is that the 30s, and then we'll learn in a minute the 60s, have this pair of values for the sine and the cosine. It just switches back and forth and changes sign based on the location of the quadrant we're in. So, what I do is I look, well, which one is 1/2? One of the two coordinates, either the y or the x, would have to be 1/2, and this one's the one that's halfway. So the cosine is the 1/2, excuse me, the sine, because it's the y value, is the 1/2, and the value that always goes with 1/2 is root 3 over 2, so that's the cosine. Again, we're going to extrapolate that. So let me get red so I can match the color. Let's come over here. All right, first of all, what degree measure is that? Well, if this is 30, 60, 90, plus 30 is 120, plus 30 is 150. So that's 150 degrees. Let's count it out in terms of sixths of pi. Pi over 6, 2 pi's over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Now, if you think about what I just said, a couple of those other ones have other numbers that we associate there, like 3 pi over 6 is pi over 2, 2 pi over 6 is pi over 3, and so on. But it helps you sometimes to think in terms of sixths. Try to fix my equal sign. Okay, what's the ordered pair there? Well, again, the y value is at 1/2. So the sine, 1/2. The cosine, negative, because of the quadrant location, root 3 over 2. Same triangle. Same triangle. And ordered pairs. Again, we have this one negative root 3 over 2 and negative 1/2. Okay, making sure you see that negative sign there. And so that angle is, let's see, 5 pi over 6, 6 pi over 6, 7 pi over 6. For degree measure, it's whatever 180 plus 30 is, which is 210 degrees. Over here, this is 330 degrees. Or, and this one I'm going to think differently. I'm going to think all the way around is 2 pi, or 12 pi over 6. So this is 11 pi over 6, ticking back by 1. 11 pi over 6. Ordered pair, positive root 3 over 2 for the cosine, negative 1/2 for the sine. And there's one more family of these, I think, might be two. Let's go ahead and take a look. Your 30, 60, 90 flipped the other way, flipped in the other direction. So let's look at this one. So again, 30, 60, 90 triangle. Oop, didn't mean to do that. 30, 60, 90 triangle, right here. Same sides, one for the hypotenuse, long leg, root 3 over 2, short leg, 1/2, in a different orientation. So now it's the x that's at the 1/2 mark. The x that's at the 1/2 mark. So its cosine at 60 degrees, the cosine at 60 is 1/2. The sine at 60 is the root 3 over 2 because they go together. 60 degrees is pi over 3. If I draw the same triangle over here, they didn't give me little dots this time on there. Same triangle, this is 2 pi over 3. It's also, let's see, 90 plus 30, 120 degrees. And the sine and the cosine there are going to be negative 1/2, positive root 3 over 2. Now, I'm not going to keep filling that in at this point, only because I think you've got the right idea, and you can go around and fill it in the rest of the way, and you're going to have to do it at the end of the video anyway for a unit circle that's PDF. Well, I guess I'll probably give it to you in class today. But you can keep going, draw your triangles, figure out what your unit circle values are going to be there. Let's take a look at what I had next. Okay, I guess the only other thing I wanted to do real quick was to remind you that you actually know the sine and the cosine of a couple more values here. Let me draw my own little unit circle. That's close, not bad. So, the cosine, remember it's cosine, sine, x then y. The cosine of 0 degrees, the cosine of 0 degrees is 1, because that's the x value here. Remember, this is 1, 0. And what's the sine of 0 degrees? It's 0. Up here, cosine sine, 0, 1. So the cosine of 90 degrees, right here, cosine of 90 degrees is 0, and the sine of 90 degrees is 1. Over here, negative 1, 0, cosine of 180, over to 180. Cosine of 180 is -1. Cosine of 180 is 0. Sine of 180 is 0, sorry. And 0, -1. Cosine of 270, 0. Sine of 270, -1. So we're going to fill in this last part, this unit circle, and then what we're going to end up doing in class after this is we're going to take the unit circle and we're going to unwrap it as if we're unwrapping it on the coordinate plane, and we're going to get something like this, where one whole circle gets unwrapped and you get a sine wave. And that's why we've been learning about periodic functions. So let's fill in this unit circle and we'll be all done with this video. If you want to, go ahead and fill in your own copy, but I'm going to go through and start at the beginning and fill it all the way in with degree measures, radian measures, and unit circle ordered pairs. Okay, so start at the beginning. 0 degrees, 0 radians, ordered pair of 1, 0. My next is 30 degrees, pi over 6 radians, and again, not memorizing. Y value, 1/2. Putting the x value at root 3 over 2. The next one's a 45. That's pi over 4 radians. And that's the one that's root 2 over 2, root 2 over 2. Okay? Next one is 60 degrees. Pi over 3 radians. Again, not memorizing. Thinking, all right, whole pi. 1/3 of the way, pi over 3. Or 2/6. 1/6, 2/6, pi over 3. This time, the 1/2 is at the x. So the cosine is 1/2, and the sine is root 3 over 2. 0, 1 is the ordered pair here, and that's at 90 degrees and pi over 2 radians. All right, 90 degrees plus 30, 120 degrees. 2 pi over 3 radians. Think of it in terms of sixths. 1, 2, 3/6, 4/6, which is 2/3. Okay, and again, the x is at -1/2, so -1/2. Positive root 3 over 2. The next one is another 45. That's 135. And notice the difference between them is 15 degrees. That'll make this one 150, just to get ahead of myself a bit. This is 3 pi over 4. And it's negative root 2 over 2, positive root 2 over 2 for the sine or the y value. Okay, almost half done already. All right, this one is going to be 5 pi over 6. That was the 150 degrees. And again, I can count them. 1, 2, 3, 4, 5 pi over 6. And that's going to be 1/2 mark for the y. Negative root, gotten around here to 180 degrees, which is pi radians, which is -1, 0. Cosine is -1, sine is 0. Oh, apparently I must have crapped out on that previous one. Sorry about that. I think my palm hit the pause button. Okay, continuing on. Now we go from 180 to 210, 30 degrees more. It's 7 pi over 6. And again, looking at my values. The y is at -1/2. If I know that, I know the other one, and I just have to think about the quadrant I'm in for the sine part. Okay, sine is an S-I-G-N, not S-I-N-E. All right, 210 plus 15 is going to give me 225 for this one, which is 5 pi's over 4. Okay, 5 pi over 4. And that one's going to be, again, root 2 over 2 and root 2 over 2, but they're both negative because we're in the third quadrant. Hold on, did I do that previous one right? Yup. All right, almost 3/4 done. 225 plus 15 is 240. And this one is going to be 4 pi over 3. And this one again, not memorizing. X is at 1/2 or -1/2. So this would be negative root 3 over 2. All right, 270 degrees is 3 pi over 2. 0, -1. So our sine is -1 and our cosine is 0. Continuing, 300 degrees. Not 360, 300. Sorry, messy. And that is, let's see, if this is 4 pi over 3 is 8 pi over 6, 9 pi over 6, 10 pi over 6, 10 pi over 6, which is 5 pi over 3. And see, I don't memorize. I'm figuring it out. My x is positive 1/2. My y is then negative root 3 over 2. Almost done. 315. And then I'll go ahead and put it in. This is 330. This is another 45. So it's 270 plus 45, which is 315. And if this is 5 pi over 4, this is 6 pi over 4, this is 7 pi over 4. X value root 2 over 2, Y value negative root 2 over 2. And then up here for 330 is 11 pi over 6. Remember we did that in the previous, one of those previous slides. And again, not memorizing, Y value at negative 1/2, root 3 over 2 for the X. And we get back to the beginning with 360 degrees and 2 pi radians. And we have filled in the entire unit circle. Well, I hope you enjoyed that. We are going to draw this from scratch. It'll be the last quiz you take this year. So you are going to have to draw it from scratch for me at some point soon. Thank you for watching. I will see you guys in class.